Hi everybody, broadcasting from Philadelphia still, and this might be my favorite visualization so far because it highlights and illustrates maybe the main mistake that you can make, the biggest mistake that you can make when you are doing data science, and that's called overfitting. So let's take a look at that. So first of all, one thing that I didn't point out in the last one was that you can definitely find the line that will give you the minimum root mean squared error. So you can find the best fitting line. We weren't exactly doing that. We were just sort of eyeballing things, moving sliders, trying to make this as small as possible. But you can find the line that will minimize this quantity, and that's what I've done here. So this blue line here is the absolute best fitting line to this cloud of points. So it gives us a root mean square error of 6.96. So it seems like this line would be the best estimate of the true underlying function or line that gives rise to these points. And we'll take a look at what that is at the end. But, so why do I think it's the best? Because it gives me the smallest root mean squared error. It's the line that's closest to this collection of points. But what if I did the following? I'm going to come down here to these radio buttons and I'm going to click 2, and you can see that I've changed now the estimating function. I've taken the first half of points and I found the best fitting line to those, and the second half and I found the best fitting line to those, and just connected them. And that, of course, is going to make this function closer to this cloud of points. And you can see that it reduced the root mean squared error. So perhaps this is a better estimate of the underlying function that gave rise to these points. Let's keep going. So let's click 4 here, and let's do that for every group of 4 points. Find the best fitting line, find the best fitting line, again and again, connect them all together. And of course, that reduces the root mean squared error. So why isn't this here the best candidate of the 3 that we've seen so far? But the best of all of them would be this one. Just connect all the points. The root mean squared error is 0. The distance between this function here and all these points is 0. All the points are actually on this function. This seems like this is it. This has got to be it. This has to be the winner, right? But if we now take a look, we can see that these points came from this red line, which doesn't look anything like what we've obtained. It actually looks more like what we had to start with. So what is going on there? And you'll see that that's the case. So we can refresh these points, right? And you can always reduce the root mean squared error all the way down to 0. But at least in this visualization here, the points are always coming from a straight line. So what's happening? That would be a good discussion, I think, to have with the students. So I'm going to continue along that theme in the next one. But what we're doing here, when we keep reducing the root mean squared error all the way down to 0, in fact, is we're overfitting. So I'll try to explain that more in the next video.